Network Automation Nerds podcast. Hello and welcome to Network Automation Nerds podcast, a podcast about network automation, network engineering, Python, and other technology topics. I'm your host, Eric Cho. In today's episode, we welcome Damien Garros, CEO and co-founder of OpsMill. From what I could gather, OpsMill is a platform designed to make infrastructure more agile, robust, and well-documented. Of course, we'll ask Damien more about the details of it in today's episode, and today and next week's episode. So I first became aware of OpsMill after the recently concluded AutoCon 0. Many of their colleagues came away impressed and excited about what Damien is trying to build. So I reached out to Damien, and he graciously agreed to come onto the show, and I am super excited. So let's dive right in. Welcome, Damien. How are you?
Hey, thanks. Hi, Rick. Very nice. Very happy to be here and share more about what we're working on. So thank you for the intro.
No, the pleasure is all mine. Like I said, there's a lot of people, in particular, Kirk Byers, right? Like he's the creator of NetMiko, for people who's not familiar. So well-respected, one of the most widely used tools. He came away and said, hey, this is the product that I'm most excited about. That, I hope I didn't, misunderstood his tweet, but if I did, it is what it is. I mean, I'm sticking to my story anyway. So it's great to have you here.
Yes, thank you. And thank you, Kirk. And quick fun story about AutoCon, actually. One part I really loved, at the end, I think they had like a panel and Kirk was on it. And
sure.
Everyone that would actually come to the mic would say thank Kirk because for all the work that he does for the community.
Right. Everybody was like, hey, can I kiss the ring? Or
that was very cool. I really I think it was very nice because he's doing a lot of stuff, and so he deserves a lot of credit for it. So.
Oh, definitely, right? Like, and I mentioned multiple times I've taken Kirk's class, like the free one, and then I took the paid one. I met him up when I was in San Fran, so I reached out to him constantly. So, I mean, he's just a nice dude, and he's doing a lot of good stuff. So, if I were like attending AutoCon, unfortunately, I couldn't make it this year, but I would be like, hey, Kirk, I'll be like a fanboy moment too.
Definitely.
Yeah. All right, cool. So, Damien, I mean, let's get back to the origin story, right? So, I mean, all the guests, I'm always interested in how they get into networking, how they get into technology. Were you like a child prodigy? Write your first game when you were 5 and sold it for billions, or what?
I was not. No, actually, fun story. When I got my master, I was barely speaking English. I almost didn't graduate because I couldn't speak English. And I think the first class, they thought I was like desperate because I couldn't write code and I didn't understand how IP address subnetting was working. So I definitely didn't do all of that when I was 8 years old. I started as a pre-sales, first working for a VAR.
Okay.
I made my way into to Juniper. And then that's really when I started being at Juniper that I really started understanding like the power of automation.
Yeah.
At the time, I was working with a very big customer in France, and I was doing a lot of network design for them. Like that was part of the SE role. Like we were always designing same time as the project. And very quickly, I realized that Junos had all of those features at the time, and I could use those features to improve the design.
Right.
And it started making a lot of sense to me. Like, hey, as a network architect, I have all of those features that I can use to make the design more efficient and the networks and all of that. So I started working on that. I remember, I think my very first features was they were missing something in the product to monitor some of the internals, and the customers really wanted that. We ended up hacking something in, I think the name was Slacks at the time. It was like the pre-Python world in Juniper, and that actually helped us win the deal. And from there, I pretty much, at some point through Juniper, managed to get into the US.
Mm-hmm.
So in 2013, I moved into Juniper engineering.
Mm-hmm.
My English was still very bad at the time, so I didn't want to be customer facing. So I ended up joining like the sys team. And my role was actually to write an automation platforms to test some of their, biggest switching products.
Yeah.
And so that was
the EX line, or was it?
It was the QFX line. So my job was actually to write an automation suite they will let us test the biggest QFabric they had, like 6,000 10 gig ports. We had, think about 100 Spirent ports. That was a beast. That was just, exciting. And so I built some automation for them, and then very quickly I moved into like more technical evangelist for the automation stack and the technical marketing. And then after that, I joined Abstra, learned a lot at Abstra, and then I moved to Roblox, where I got a chance to be the first member of the network automation team.
Right.
So did an amazing project there, and then I really wanted to basically take everything we did at Roblox and make it available for more company.
Right.
So
Are you talking about Roblox, like the gaming?
Yes.
Oh, okay. Oh, wow. Interesting. I didn't know that. It seems very different than Juniper.
Yeah, very different. But when you're TME, I think at some point you're talking a lot about the technology, but you're always doing demo.
Yeah.
At some points you get a bit frustrated that you're not actually doing it for real, and you feel like a sense of it's missing. So I really wanted at some point to go on the other side and actually do it on the customer. So I was very happy. And again, Roblox, I was so lucky. Like I joined just before at the time when they started rebuilding everything. So in 18 months, we deployed 12 POP worldwide. We rebuilt 2 data centers, migrated another one. It was just a crazy time, but super exciting.
Yeah. I mean, I have 2 kids, right? So I am, familiar with all the block coding, maybe like the Raspberry Pi stuff, Roblox certainly. So it's kind of interesting to hear your thoughts on, just kind of the back ends of it, right? So a lot of startups choose to start with the cloud, but it seems like Roblox kind of want to own that stack.
Yeah, because they actually run the games for all the players. So and also there's a lot of traffic. So at the time it was making sense. And also like initially it was interesting, but initially the game engine was actually all in Windows.
Oh no.
When I was there, someone actually managed to migrate everything to Linux and containers and all that. But initially there was a lot of that. So, and I think they had better performance on their own hardware. So
yeah, I mean, I've seen obviously because I worked at the design and Azure, so I've seen a lot of companies started there, but there's also many companies choose to, whether by regulation or whether by security, choose to have their own stack on-prem. And also I've seen companies such as Box, they started out online in the cloud, and then Dropbox, and then migrated to their own, because at some point it's actually cheaper to run your own than to do a hosting.
Actually, a big part of the team at Roblox came from Dropbox, because the VP at Roblox was actually one of the member of the team at Dropbox that did that migration.
Is that migration? Oh wow, yeah.
A very small world, but that was a very interesting time. But it felt like all the cool things we built were really custom made, a lot for us.
Right.
And in a sense, I wanted, to take that to the rest of the industry. I wanted to try to see if we could build that like more of the shelf solution that more people could use. So that's at the time I had the opportunity to join Network to Code. And then I got exposed to a lot of different customers. My role was really like partner with our customers, help them define their automation strategy, and then help them implement that strategy, define the architectures, work with our team, write the code and all that. So that was very exciting. It gave me the opportunity to try a lot of different things. And I was working a lot at the time. Like we were all about the source of truth. So we're doing a lot of projects with Netbox and then Autobot. We put a lot of ideas on. We were always trying to see how we could take those platforms further and further and further.
Right.
And that's how we came, with Autobot. And I think at some point it always felt like all of my customers, the conversations will end up being, hey, how can I have the best of infrastructure as code and the best of Autobot or Netbox? Which means like they wanted a UI, they wanted to have an API, they wanted to have all of that, but they also wanted the flexibility of Git and version control. And that's probably the summary of my last 5 years of my life. Is how do you do that? Trying for 5 years, it feels like we might not be able to succeed, with the current solution. And I really feel like, strongly that we had to maybe start from scratch, and redesign exactly the right components, so that we can go into more details on that. But that's kind of the genesis of OpsMill, and why we ended up like building that.
Yeah, definitely. I mean, first, I want to just kind of thank you for even having the mindset of trying to share something that's proprietary or somewhat closed doors for the community, right? Like, not everybody think that way. I won't name any names, but it's definitely, a lot of times there's a hoarding mentality. This is our competitive advantage, right? Like, this is where we make the money, and we can't give our secret sauce away. But first of all, I want to thank you, and I think the community benefits from it, of having this, kind of a Linux and GNU mindset of, trying to share with the community. And of course, let's talk about it, right? Like, so I put up, for our listeners, I mean, if you're listening, that's great. We'll have the link in the show notes. But for those who want to or have the capacity to look at the YouTube channel, we actually have Damien's presentation slides, and he's going to drive a little bit on, just talk to us through the start of the OpsMill, and also what problem they're trying to solve. So let's start with, because that's where you kind of left off, right? Like, you think you're going back to the drawing board. So what problem is OpsMill trying to solve?
So I think we kind of already started on it. It's like, to automate, everyone that I've seen that have been really successful in automation had built a platform that has many components, and usually in the center you have the source of truth.
Right. And by source of truth, what do you mean, right?
What I mean is
For
like
people who's not familiar with it.
place where you store the expected state of your infrastructure. That's what I define my source of truth. By the way, if I can say, I hate this term, source of truth. I use it all the time. I feel like it's too generic, and every other person has a different opinion of it. So
right. What do you mean, like a spreadsheet, or
that we move past source of truth and we find a better name for it. I have a few proposals.
Okay.
But you have a data set in the middle, and this data set is captured the internet state of the network. And then that's what drives the automation, and all the other components connect into that source of truth. And one which we're seeing is, today, most people actually have been reinventing that component on their own. And actually, the most successful organization I've seen, they've been building their own database.
Right.
Which is like what we're seeing, like there's really two category of solutions. Like, either people put all of their data in a database, and I think the most successful, they are using their own database. Now there's a big part of the industry, they also use Git as their source of truth. And they store everything in Git. So it's really this trend that we call infrastructure as code. And of course, in the database, you have the netbox and the nanobot and all that. But what we found is that the really important features of the source of truth is, you need to have a very flexible schema, and you need to have version control, or at least you need to be able to control how the data gets in, because this decided that everything that gets in gets deployed.
Right.
And so it's super important. And I think actually the closest tool that has those two capabilities is probably Git, because in many ways, Git is super flexible for the schema, because it doesn't really have a schema.
Right.
Then it's super. It has the version control. Now there's a lot of downside to that, but so that's what we're seeing. And again, our analysis has been that, why do we have two different systems? It's because if we look at them, and I pass some of those things, that they have different capabilities. And if you look at, again, that's after going to the whiteboards and all that. Like, if you look at what an engineering team needs to do on a day-to-day, they need to manage standard changes like adding VLANs, adding new services, just adding to their infrastructure.
Right.
But they also have to manage migrations and design changes, and like changes that are a lot more complicated and undefined in many ways.
Right.
And what we're saying is pretty much to manage those different changes, you need different solution. Like when you're actually managing a day-to-day change, those are very well understood. You can easily manage that. You need to have like an API, you need to have a forms, you need to have all of those things, which fits perfectly with the database approach.
Yeah.
It's really easy to deploy those changes that you understand if you can codify them when you have a database at the center, because you have the APIs, you have the reactivity, and it's easy.
Yeah, very structured, right, and very well understood. So you, like you said, if it's understood, you could codify them, and then you could kind of repeat and rinse.
Yeah, but all those hard changes, those non-standard changes, like when you do design change, those are much more complicated because you want peer review, you want an isolated environment, you want to potentially you will take multiple days to prepare your change,
Right.
and those are really hard to do in a database first approach in a database system, because you cannot just have a staging environment of your database.
Right.
So you have to prepare everything outside, but you never have the full visibility. And that's exactly what Git provides. Git is so good at providing an isolated environment. You can do peer review, like complex changes are super easy to manage with Git. But on the other side, Git, you don't have a query engine, you don't have a schema, the UIs, there's no like user interface, you don't have APIs. So there's all of those things. And again, the analysis has been pretty much like we have two main changes that we need to manage, and we build a solution for each of them. But the issue is we need both. Like, I don't know a single environment that doesn't need to provide those type of changes. And I think that's where, we have all of those struggle today, is like, if you are in a situation where you goal of your organization is to automate the standard changes, then you will go for a database first if you're looking for the other one. But there's no solution today that can provide both. And that was really, when we realized that, was okay, how we went back and then say, okay, so we need to have version control, we need to have a very extensible schema, we need to have the query engines and all of those things. And that's why we started OpsMill pretty much.
So, I mean, let's double click on that Git first a little bit, right? So we have that graph on what you talked about, the rigid, changes that you have the DB first, and then you have the Git first. So why can't we have, like Git first, but also have I mean, when you talk about you don't have the schema, the rigidity, it's because Git is so flexible, right? It allows you to do anything as long as it's, kind of text based. But why can't we have like guardrails around it so that we protect the DB schema and have it use it in parallel? I mean, is that are you aware of any solution on the market that does that, or are you just saying that is why we're doing it?
Now, so there's actually multiple solutions now that are coming up. Like this idea of bringing version control and change control into a database, it's actually growing, and there's multiple solutions out there.
Okay.
So, for example, there's Dolt, and at Network to Code, we started exploring how we could take this new database, which is pretty exciting. It's like a MySQL database, it's MySQL compatible, and it has all the construct of Git internally, so you can actually create branches in this database and all of that. So,
oh wow,
pretty exciting. And we started looking at how we could integrate that with Nanobot.
Right.
So there's a lot of that. Now, why we didn't go with those databases? I think the challenge for us, as you remember, is we have to manage to do the version control, but we also have to have this extensible schema.
Okay.
The issue with the relational database is that that's the opposite of a flexible schema. Like a relational database, by definition, the schema is very, it's kind of in the kernel space, very low level, and then changing the schema is a really big operation, and you don't have a lot of there's a lot of constraint to that, and also like because everything is stored as stable. So it really feels like if we accept that the main goal is having a very flexible schema, we should not use a graph database, a relational database. Like that's never going to work, because it's kind of the opposite of what our relational database. Relational database are, you define the schema at the beginning, and then you have the super performance system that will let you consume that, but it's not about extensibility.
No.
And that's kind of when I realized that, and I realized that, Django and Netbox and nanobots were really built around this relational database and that it will never go away.
Right.
Not in those technology stack that I started looking elsewhere. And maybe it's worth stepping back a bit, but or maybe we'll come back to that. For me, I actually I told you after Juniper I went to Abstra.
Yes.
One thing that I learned, and I was in
Yeah. For people who's not familiar with Abstract, can you just tell us what Abstract does?
Yeah, it's a solution that's really focused on managing the entire life cycle of data center fabrics. And so it's from the design to the deployment and the monitoring, and so it was really built initially to work on any type of hardware.
Yeah.
It will like build the configurations and do everything for you.
Yeah. So it's basic. I mean, from my basic understanding, is Abstract is treating your whole network as a whole, right? It doesn't really care what components are in it. It cares about what you want to do with it, and then having more kind of an intent based instruction on. I just want 64 times 10 gig link in this layer, and I don't care how you do it. Is that
Yeah,
true or no?
yeah, that's very true. So it's really I see that as a vertical solution that
Yeah.
really addresses the data center markets and segments and provide very customized and optimized solution, again, from the design to the deployments to the operations and monitoring for those solutions.
Right. Okay.
And one thing they had at Abstra is they were using in their core a graph database. So it's actually a different type of database than the relational database.
Mm-hmm.
I think I had a slide. Let me go to that. But and what's interesting is it's those type of database.
I'm so excited you have visuals. Yeah, because it would be really hard. I mean, I might apologize if you're like driving or something and you're just trying to wrap your brain around it. But it's very nice visual, by the way. Having this relational versus graph database. But go ahead.
So honestly, the first time I got exposed, I remember I was pissed off. Actually, I didn't knew they were making that change, and I remember when they like, hey, we changed everything, and then suddenly we didn't have REST API, we didn't have all of that. We had this new interface, and that was a shock.
Mm-hmm.
But very quickly, I started working on it and digging, and then I realized how powerful those databases are because they actually it's funny because relational database have this name relational in the name, but it's actually graph database are really designed for relational data. And you have much more flexibility on how you connect things. You don't have the constraints of if you had an attributes or a relationship, you have to apply it to all of them. Like it's much easier to extend the schema in this environment and super powerful. And so yeah, I was exposed to that, and so it's pretty much since my Abstra day, I was always in my back of my mind, it was like that's the type of technology we need to use. That's the type of technology we should use. Except at the time, the ecosystem was not using any of that.
Mm-hmm.
And so when I really finally gave up on relational database for solving the network source of truth problem, that's pretty much where my mind went. And after studying that for many years and looking at how we could do that, I found that there's actually techniques of how you can store the data in a graph database that makes it what they call is a temporal graph. So it's a way where you never delete any data and you have ability to travel in time in all of your data and go back to your past versions and all of that. So it was a very interesting concept.
It sounds like magic. It sounds like Doctor Strange.
So no, it's a very there's a lot of paper on it, and but pretty much what we did is it was like so we like this idea of temporal data, and we can immutable database, and we can navigate it down. And what we did is like could we actually extend that in multiple dimensions so that we just have one temporal database, but we also could have multiple branches of that database. And that's pretty much what we end up building. And that was really the genesis of OpsMill and specific InfraHub, which is the solution that we're building.
So can you? I mean, since we have the graph up, relational versus graph, right? Can you give a little bit of example, because I think this is where people will have question about, or like our listener will have question about them. Like many like me are familiar with the relational database and the rigid structure around it, right? So for example, for something like Nautobot or for Netbox, you have to define like a region, and then you have to define like, physical locations, the East Coast West US, East Coast US, West Coast US, North European, South European, whatever. And then you have that relation into that region. And then you have your devices within the data center within that region. So these relations don't change, right? And it's perfect for a relational database. But can you give us some example on the relationship that is not suitable for a relational database, and therefore a graph database would be perfect for it?
Yeah. So, and actually, that's maybe a parallel to like what we're trying to do with Netbox and Notebot.
Hmm.
And something I'm speaking in this presentation is, you can step back a little bit. I come back to your question.
Sure.
Like, I think in the last, um, 5 to 8 years, we really embracing this idea, started, embracing the idea that, we need to put more data into the same schema or in the same place so that we can connect and capture the relationship between those different data. I really think when Netbox came out, that was the first time, at least for a lot of people, we had IPAM data with DCIM, with circuit information in a single place, with nice API, and it was easy to consume. And so we saw the power of having a lot of different data from a lot of data sets that used to be separate
Yeah.
in a single database so that you can make query. And I think over time, when Netbox started having plugins, then we were able to add more, and then we started to extend the type of data. And for me, that was really like an eyes opener of like, the more we put data, the more we can capture this relationship, the easier it is to actually manage this humongous amount of data. And at the result, like we have better data. When we make a change, we can understand the impact of those change, and we don't have to have duplicate data sets that gets out of date and all of that. And there was also this idea that there's all the technical data in there, but we were seeing customers, they wanted to have, different information, like design information, like they wanted potentially to have customer information.
Oh, I see
So
what you're saying. Okay.
imagine now that you want to represent a customer, and you want to create a new table in your system that represents your customers. And now you want to capture the relationship between your customers and every single technical elements or resource that it uses, whether it's IP address, VLAN, interface. So do you understand, like, technically you should build them for that. That's the kind of relationship you might want to create in your database. But in a relational database, if someone provided this initial schema for you about the IP address and all that, you actually may not be able to create that relationship, because that would require, for example, if it's a one-to-one relationship, that will require us to change the dimension of the initial table.
Yeah.
And that's something you could not do. So that was something we were always fighting at Network to Code is, the system was coming with a default schema, and then we wanted to provide extensibility, but there was a lot of things that were not possible. So we were providing, like, I actually developed these features in Autobot called the custom relationship.
Hmm.
And we did it in a way at the time that we were using, like, because we couldn't extend the table of the existing objects, we had to do it in a less performant way. And then we were trying to do our best to make it, super easy to consume from the customers. But the truth is, like, there was a lot of very technical things happening in the background. And I think we always had like a performance hit because those relationships were not as performant as the other one. And that was just, super complicated to manage all of that. So
Yeah, it
hopefully
almost seems like, sorry, cut you off. Go ahead.
no, hopefully that answer your question.
Yeah, I think that did kind of get a glimpse into the starting point of why you face this problem, right? And just like the real world, there's some relationship that are very straightforward, one to one. Like the circuit has one circuit ID, right? Like so that's easy to come up with that mapping of the relationship. But there's also very complicated relationship um that are very hard to grasp and dynamic, right? Like, so if I give my own like example of a family, I mean, I have relative who were like divorced ones, and for both the husband and wife, and then they get remarried and they have kids again. And so those are like kind of dynamic, and your kids and my kids and our kids, and like like the family tree becomes very commingled, and that seems to be a shortcoming of a relation database when it's dynamic and hard to map, like the dotted line almost.
Yeah, that's a good. And so one thing I realized at some point is, this idea of putting a lot of different data in the same database and
Yeah.
in a single schema so that we can make very advanced query to understand and we basically extract more value from those data.
Hmm.
It is actually not something that's specific to our industry. It is actually something that exists also in other industry, and there's even a market for it. Like people call that knowledge graphs.
Hmm.
They found that in retails, in pharma, in cybersecurity, in a lot of different places, people have been doing exactly the same. They realized that we need to have a super flexible database where we can have a very flexible schema, and then we put all of those data in central place. We create those relationships, and if we have a very powerful query engine, then we can do more with our data.
But why do you even have a schema at that point, right? So, that reminds me of the non-structural, a schema-less or a NoSQL database that you just put whatever junk you have in there.
Yeah, the schema helps with the integrity, and the schema helps with the query engine.
Sure.
And it helps you actually know what you have. And so yeah, I think it's super important. And pretty much, when I started realizing that, okay, so what we're actually trying to solve is also happening in other industry,
Right.
then maybe we should pay more attention and understand. And I
Maybe.
think when I started looking, I realized that all of them are actually also using graph database. They all came to the same conclusion that to solve these specific problems, you need to have a graph database. And I think from what that was probably one of the confirmation. Like I already had this idea that we should move to a graph database, but then when I looked and said, okay, they're doing very much what we're doing, and they also have a graph database, then that was a confirmation that that's what we need to go.
Hmm.
And so yeah, that's I really wish we would actually pay more attention sometimes to what's happening to other industries. I think there's a lot to learn from other industry and what they're doing, because our problem are specific to us, but they're not that unique in any way. Um,
I so want to double click on that, but this is probably a good point to wrap up. If this is interesting to you, make sure you stay tuned for the next episode where we'll dive more deep into it. So thank you for being on part one of the recording, Damien, and we'll resume our conversation for the next session. Is that cool?
yeah, thank you very much.
All right, cool. Thanks for listening to Network Automation Nerds podcast today. Find us on Apple Podcasts, Google Podcasts, Spotify, and all the other podcast platforms. Until next time, bye bye.